In this example, we look at an application. Suppose in 2010, a country recycled 73 million tons of solid waste. In 2013, the figure grew to 85.3 million tons. Let's let N of T represent the number of tons recycled in millions, and T the number of years after the year 2010. Assume that a constant rate of change exists for the model formed. That just means the slope is going to stay the same from year to year. In part A, we're going to find a linear function that fits the data. They also call it a model, a linear model. Okay, well, a lot of jargon. Don't let it intimidate you. Realize when we're finding a linear function, that's the same thing as finding a linear equation, y equals mx plus b, except we're not going to use y, we're going to use function notation. N of t we're told to use. And, oh, that means the input is t, so it's going to be m times t plus b. You don't even need to worry about that at first. We can stick with y equals mx plus b and then change it at the end. Okay, so we need to find a linear equation that fits this data, which means we need ordered pairs. How do we find ordered pairs? Okay, well, we're going to take this data and make it an ordered pair. But the year 2010 is going to be year 0. How do I know that? Because it says let t represent the number of years after 2010. Remember, the value that represents time is going to be your input, so it's a first coordinate. So 2010 is going to be year 0. That's going to be a first coordinate. And just 73 is going to be your second coordinate. In other words, we get the ordered pair 0, 73 from these two data values. And then from the data values 2013 and 85.3, well, think about it. 2013 is 3 years after 2010. So that's going to correspond with an input of 3 with an output of 85.3. So 3, 85.3. So we've got two ordered pairs. Let me write them down again. All we need to do is find the equation of the line through these 2 points, 0.73 and 85.3. So now you have to decide which of the two forms do you use. Do you use slope-intercept form, y equals mx plus b form, to find the equation of the line? Or do you use point-slope form, y minus y1 equals m times x minus x1? Well, here's a big clue. There's a 0 as one of the inputs, which means this point is a y-intercept, which means 73 is b. Oh, so we know what b is, which means we're going to use this equation as I kind of gave away earlier. So don't even worry about n of t. Let's just use y equals mx plus b for now. What does this equation or this form of the line tell you you need? Well, you need m and you need b. You've already got b. b is 73. So we need m. Oh, how do we find m? Oh, that's just the slope between these 2 points, isn't it? It's also the rate of change. So the slope is going to be 85.3 minus 73. That's the rise. So, focus your eyes on these two values. Take 85.3 minus 73. That's your rise. And your run is going to just be 3, isn't it? 3 minus 0. And so you get 12.3 divided by 3, which turns out to be 4.1. And as just a review, remember the units of slope. This would be in millions of tons, so it'd be million tons per year, which means the amount that's being recycled is going up by 4.1 million tons per year. Okay, that was just review. All we really need is this number here. And so now what we can do is we can fill in y equals mx plus b. and get y equals 4.1 times x plus 73. But you were told to write it as a function n of t. So replace y with n of t. And then that automatically means the input, instead of x, it's got to be t. So the way you're going to have to write your final answer, n of t equals 4.1t plus 73. That's your linear function that models the data. In part B, let's use the function from part A to predict the amount recycled in the year 2020. So the key thing to remember here is that we're actually starting our time value at 2010. The year 2010 is year 0, so the year 2020 is the same as year 10. It corresponds to t equals 10, doesn't it? So what we can do is we can take our model and find n of 10. N of 10 would be 4.1 times, you're just going to plug in, remember function notation, you're just going to plug in 10 right there. So 4.1 times 10. And then you're going to add in the 73. And so that's actually going to be 41 plus 73, 114. And what is that? That's in millions of tons. That's 114 million tons. That will be recycled in 2020. In part C, if this model holds, when will 120 million tons of solid waste be recycled? So remember, this is our model, and n of t represents how many tons, how many millions of tons of solid waste that's being recycled. T is just time in years after the year 2010. Oh, so the word rather, when, is kind of key as to what it is we're looking for. We're looking for a t value here, not for an n of t value. So when that's the case, just take your linear function, your linear model, and we're going to be replacing n of t with 120. So that you end up solving the equation 4.1t plus 73 equals 120 if you want to turn that around, not that you have to. Okay, so subtract 73 from both sides, get 4.1t equals 47. Divide both sides by 4.1, get t equals, if you do that on the calculator, which I'm doing real quick, 47 divided by 4.1. If you do that division, you get 11.46 approximately. This is very approximate, wavy equal sign there. And so depending on how you want to round, you can answer the question. If you round to the standard rounding convention, round down, which maybe you don't want to do because you might want a conservative estimate, you might use 11 years, or if you're being more careful, you might use 12 years. But remember what this is. It's 11 years after 2010. So you could say in about the year 2021, 2022, the amount of recycling will be about 120 million tons.